Here is where the number line gets fascinating. We left off asking about this number line. What is to the far right and what might be to the left? And it leads to a technicality of number lines, the arrows at the ends. And no, I didn't have the arrows in the first video because we need to slowly lead up to that. The arrows are important because they denote that there indeed is something to the far right and to the left, maybe. It all depends on the type of numbers that we are talking about. And yes, numbers have types or classifications. We call them sets. And it's extremely important to know which set of numbers you are working with at any point in time. The first set is the counting numbers or natural numbers, numbers that we can point to or touch. Now, we began working with these numbers in part 1. The next set of numbers is the whole numbers, which is the counting numbers, and 0 or a whole. For both of these number lines, there's only one arrow to the right because for each of these number sets, there are no numbers to the left. But we left off with wondering what might be to the left. And of course, that's negative numbers. And we are now in a different number set called integers. And here we must pause because we have to understand the integers and how they work. And so we have to go back to some of those number puzzles where we can figure out missing numbers or previous numbers or next numbers in a sequence. And so we're going to need to practice that. And if you need, you may have to have your child write their own number line because that's a good way to get them to understand how they work. And now it's time for a brain stretch. Back to those arrows. They denote continuity in that direction, which begs a question. How far in that direction? How many numbers are there? So let's start with the counting numbers. Remember, they begin with 1 and only include what can be counted or pointed to, that one-to-one correspondence. That's the counting numbers. Well, how many counting numbers are there? Think of the largest number you can, let's say 1,000,000. Are there more? Yes, right? The arrow still goes to the right. What about some number that is ridiculously large, maybe a digit and then 1,000,000 zeros after it? Are there more? Yes, of course, no matter how many numbers you can point to, there will still exist one more number that you can point to. And this, of course, is the concept of infinity. Now, your child may not get that, but that's okay. All they need to know is the question, are there more and how many more? Heck, you may have an issue wrapping your head around this, and that's completely understandable because it's insane. Are you buckled up? Good. Remember, we were talking about the counting numbers, right? And there are infinitely many of them. Well, remember the whole numbers? They were the counting numbers, but they start at 0. So how many whole numbers are there? They go on forever, so also infinitely many. And remember, the integers, they have negative numbers too. That means infinitely many integers to the right and infinitely many to the left. So, which set of numbers has more numbers? They're all infinity. But something's going on here. Are you ready for this? Some infinities are bigger than other infinities. Now, if you can wrap your head around this, that's awesome. And if your child can wrap her head around this, that's just amazing because there's more. You see this number line? The line itself is connected, right? And that's another technicality, just like the arrows, and it means something. So take a look here between 0 and 1. Are there any numbers there? Of course, fractions. And that brings us to the next number set called rational numbers, numbers that can be expressed as a fraction. But check this out. Look here, then, but then, and then. So guess how many rational numbers there are? Yeah, infinitely many. And keep in mind, we've only been looking here. This very same thing is happening between all of the integers, both positive and negative. But wait, there's more. For fractions, no matter how large that denominator gets, there's still going to be space for that connected line between them. So there are numbers there, we just can't use fractions to describe them. Enter the irrational numbers. Numbers that may exist between any two consecutive rational values. These are things like the square root of 2, or the square root of 3, or the square root of 5, because the square root of 4 is this many, or pi, or e, Euler's number. There are irrational numbers, and how many of them are there? Infinitely many. And remember, the irrational number infinity may actually be a larger infinity than other infinities. If you embark on this journey with your child, who knows what might happen? But welcome the questions. Ask some questions yourself. You may have to look things up. You may have to Google a Google or a Googleplex. You may encounter things you have never even heard of. I still do. And that's fine, because sometimes you just have to see what is out there and maybe not even understand it. Just see what is out there to have your question answered or your child's question answered. These numbers exist. They must exist. And here's the lesson. We started out with this, and we thought we knew it all. And then as we started digging, it turns out, wow, there are so many things we simply didn't know and still do not know. Don't ever believe you know everything. The more you learn, the more you realize you just don't know. And that is wisdom. And isn't that a great lesson for our children and for us all? So remember, be patient and be impressed.